Every breath you take contains something your body cannot survive without. Remove it, and within minutes, your brain begins to shut down. Within hours, your cells begin to die. Today, it's so ordinary that we rarely give it a second thought. But Earth's history tells a very different story. Billions of years ago, this same substance triggered one of the greatest biological upheavals our planet has ever experienced. Entire ecosystems were transformed. The chemistry of the oceans changed, and the atmosphere itself was rewritten. And without those events, you would never have existed. That substance is something every animal on Earth depends on. Every forest produces it. We call it oxygen. But how could the very thing keeping you alive today have once threatened nearly every living organism on Earth? To answer that, we have to travel back more than 2 billion years to an Earth almost beyond recognition. If you stood on Earth 2.4 billion years ago, you wouldn't recognize it. There were no forests, no birds, no mammals, no dinosaurs. In fact, there wasn't a single plant anywhere on Earth. The world wasn't dead. It was alive, just not in any way you would recognize. The oceans may have appeared green, rich with dissolved iron that had accumulated over immense spans of time. Life existed, but only in its simplest forms. The sky likely looked hazy beneath an atmosphere rich in methane, carbon dioxide, and very little free oxygen. Microscopic life filled the ancient seas, thriving in a world that would be deadly to most life alive today. For over 1 billion years, this strange planet remained remarkably stable. Then something changed. Not with an asteroid, not with a supervolcano, not with an ice age. Something far smaller. So small, you couldn't have seen it with your own eyes. They weren't Earth's architects. They weren't trying to transform the planet. They weren't following some grand design. They were simply surviving. And without realizing it, they rewrote Earth's future. The organisms responsible were called cyanobacteria. By today's standards, they were astonishingly simple. Yet they had evolved a remarkable ability. Using sunlight, they performed a form of photosynthesis that released oxygen as a waste product. Day after day, century after century, over millions upon millions of years, they continued releasing oxygen. If they produced so much of it, why didn't the atmosphere immediately fill with oxygen? Because Earth's chemistry wasn't ready for it. Instead, it dissolved into the oceans. There, it reacted with enormous amounts of dissolved iron. The result was a slow chemical transformation. At first, the oxygen never reached the sky. It vanished almost as quickly as it was created. Not because it disappeared, but because Earth's oceans became its first destination. Dissolved iron reacted with nearly every molecule. Over millions of years, the seafloor became layered with rust, not metaphorically, literally. Those rocks still exist today. Geologists call them banded iron formations. They preserve the chemical fingerprints of one of the greatest transformations in Earth's history. For millions of years, the oceans acted like an enormous chemical sponge, soaking up nearly every molecule of oxygen the cyanobacteria produced. But no sponge lasts forever. Eventually, those chemical sinks became saturated. Oxygen finally began accumulating in the atmosphere. Scientists call this transformation the Great Oxygenation Event. It permanently altered the course of Earth's history. To us, oxygen means life. To much of the life living then, it meant something very different. Many early organisms had evolved in an environment where free oxygen was almost non-existent. Oxygen is an extremely reactive gas. For organisms that had never encountered it, it could damage the very chemistry their cells depended on. To those organisms, oxygen wasn't the gas of life. It was a dangerous new chemical. As oxygen accumulated in the atmosphere, many anaerobic microorganisms were no longer able to survive in the environments they once dominated. Then, something unexpected happened. The same gas that allowed one form of life to thrive became toxic to many others. Scientists continue to study exactly how widespread these extinctions were. But one conclusion is well supported. Earth's biosphere entered a completely new chapter. Imagine standing on the shoreline of that ancient Earth. Nothing around you would suggest the planet was changing. The waves still rolled onto the shore. The wind still crossed the water. Life continued much as it always had. Yet with every passing year, an invisible gas was quietly spreading through the atmosphere. No explosions, no impact, no warning, just chemistry, slowly reshaping the future of an entire planet. Although oxygen proved deadly for many ancient organisms, it also opened the door to something entirely new. Over immense spans of time, life adapted. Cells evolved new ways to use oxygen to release energy far more efficiently than before. That energy helped support greater biological complexity. Eventually, multicellular organisms appeared, then plants, then animals, then forests, then whales, then birds, then mammals, and after billions of years of evolution, humans. Every breath you take today carries the legacy of that transformation. The oxygen filling your lungs is the same molecule that once reshaped an entire planet. It wasn't the end of life. It was the beginning of a different world, one that would eventually make complex life possible. A microscopic organism changed the chemistry of an entire planet, and over billions of years. That change made forests possible, whales possible, birds possible, and eventually, you. The next breath you take is more than air. It's the inheritance of a planetary revolution that began more than 2 billion years before the first human ever opened their eyes. And it's a reminder that some of the greatest changes in Earth's history began with something almost too small to see. If this story changed the way you think about something as ordinary as a single breath, hit that like button and subscribe to Earth and Ether.